This video is the first in a series of videos relating to electrochemistry. The purpose of this video is to give an overview of what will be covered in the subsequent videos. The goal of this series of videos is that by the end of the series, you should be able to, given a molecular formula, determine the oxidation number of each atom in that molecule, as well as for an entire reaction, determine the oxidation number of each component in the molecules in an entire chemical reaction. Given a chemical equation for a redox reaction, identify the oxidation and reduction pathways, identify the oxidizing and reducing agents, write out both half reactions that make up an overall reaction, write out the balanced chemical equation under either acidic or basic conditions, and write out the shorthand notation for a galvanic, also called voltaic, and or electrolytic cells. Also, by the end of this series of videos, you should be able to define and differentiate between some of the following terms: oxidizing and reducing agents, what the oxidation and reduction pathways are, be able to come up with net ionic equations, as well as pull out your half reactions, describe galvanic and voltaic cells, and compare them and differentiate them from electrolytic cells, define what we mean by the anode and cathode, and be able to identify them in the galvanic, voltaic, and electrolytic cells, identify the salt bridge, calculate the electrode reduction potential, define what we mean by current, as well as amperes. The reason that we care about studying electrochemical reactions, aside from the fact that one of the fundamental goals of any research is to understand nature, and once you understand nature, you'll be able to use those naturally occurring phenomena more effectively. Part of the reason why we care about electrochemistry is that electrochemistry is the study of storing and retrieving energy from chemical reactions. Now, in the US, the average household consumes approximately 1,000 kilowatt hours of electricity every month. And almost all of this electricity is generated at remote power plants by either the combustion of fossil fuels or nuclear fission. If we want to move away from a reliance on petroleum-based products or nuclear fission and move towards some of the more green renewable sources, we need to be able to store it. And so a clear understanding of electrochemistry is needed for that purpose. Many of the chemical reactions that we have studied in general chemistry involve the transfer of electrons between atoms. There are electron transfer reactions, such as single displacement or combustion reactions. A large number of synthesis and decomposition reactions also involve the transfer of electrons between atoms or ions. The flow of electrons between different molecules is what we associate with electricity. Basic research into the nature of this relationship may, in the near future, lead to cheaper, more efficient ways of generating electricity, such as fuel cells, in which water is typically separated into hydrogen and oxygen. It can then be recombined later to retrieve that energy.